In today's video, we are going to discuss about the charging system or the charging circuit. And in most cases, when we talk about the charging system, most people refer to as the charging port. But as the statement states, this is a system with a number of components. And we are going to discuss about all these components in this video. So the topic about the charging system is going to be divided into two. So the first part, which is this part, we are going to discuss the charging system with block diagrams. So we will talk about the block diagrams for you to understand easily. And then in the second part of this video, that is going to be the part 2, we will discuss the charging circuit with schematic diagrams. I understand most of people don't know how to read schematic diagrams, but with me, we'll take it slowly to see how we can read schematic diagrams and try to dig deep into the charging circuit. So the part 2 of this video is going to be about schematic diagrams. So we will read schematics in relation to the charging system, and we'll dive deep to make sure we understand how this system works, the voltages and the components within this system. So let's get started. Now, the charging system, basically when we talk about the charging system, mostly people will understand the charging port, right? Because that is the external view of this system. So to begin with, the charging system has a charging port, right? And the charging port is attached to the underboard, so, or what we can call a charging board, right? So this is the charging board, and on the charging board we have the charging port, and the charging port has basically 5 terminals, right? 1, 2, 3, 4. So this one right here is a V bus, and it has 5 voltage, and this other one is ground, right? So now on the charging board we also have the charging flex connector, right? So the connector is going to be right here. So this is going to be the charging connector. So now in most cases when you receive the phone that is not charging, in most cases when you change the charging connector, the problem will be solved, right? Just because most of the phones or most of the cases we have in the workshops related to the charging systems, I would say 95% is always the charging connector. And the moment you change the charging connector, problem solved, right? But it's not only the charging connector that fails on the entire system. So any other component on the charging system can get damaged as well, and we are going to discuss it and see how we can troubleshoot it with a multimeter and understanding the voltages, right? So this is the basic functioning of the charging system. So when you connect the charger, on the charging connector, it brings in 5 volts, right? So if you use your multimeter to test on the charging connector, you'll have your 5 volts right here. So the moment you have 5 volts right here, it means your charging connector together with the charger are working, right? So where else do you go after this? So after this charging board delivers the 5 volts right here on the charging flex connector right here. So you also have 5 volts right here, or on the connector for the charging flex, right? So the moment you have 5 volts right here, it also means that your charging board is okay. It means your charging board is okay. So where else do we go to? Now from the charging flex connector right here, you have the charging flex. Let's draw it like this. So you have the charging flex. Now depending on which model of the mobile phone that you're working on, in some models this flex cable is attached to the screen, and in some other models this cable is just independent. Now what you do is, after you connect this charging flex on the charging board, you have to find 5 volts on top here, right? On the connector to the logic board, you have to find the 5 volts. And this charging flex connects to the connector on the logic board. So this is the logic board connector. So the moment you test 5 volts on the logic board on this test point, this is TP called VBus. So the moment you have 5 volts on the VBus, on this VBus test point, it means your entire system downwards is okay. So that means your charging flex is okay together with the underboard and your charger. So let's say in some instance you don't have the 5 volts right here. Can it happen? Yeah, it can happen, and you have 000 volts. You get? So it can happen and you have 0 volts. So what do you do? If, for example, you have 5 volts on the charging board connector, but you don't have the 5 volts right here on the test point, it means maybe your charging flex is not okay, or this connector, the connector on the logic board itself is loose, and therefore it is not delivering 5 volts right here. So what do you do in that case? So in that case, you come here on the flex cable right here and test and see if you have 5 volts. So if you have 5 volts, then it means the problem is in the connector. So either you can change the connector or you resolder this connector, and most definitely your problem is going to be solved. So if it happens and you don't have 5 volts on the top of the flex cable, so it means this flex cable is damaged somewhere. So what you do, you take a jumper from 5 volts down and jumper to the test point or the VBus, right? Because this VBus is supposed to be 5 volts as well on the normal charging system. So after that, what happens? So the TP is connected to some other IC, the smallest IC on the logic board, called an OVP. So this OVP is a small IC that helps to protect the circuit in case you have overvoltage. And this IC is called overvoltage protection. The OVP IC, right? So this IC, in case you're supposed to charge with 5 volts, but in case the voltage increase beyond the normal that it can sustain, this circuit is going to break from this IC, and it is going to protect the other part of the motherboard. So that is the use of this IC. Now, once it gets to the OVP, it still comes out of the OVP as 5 volts. So after OVP, where does it go? So from OVP, it goes to another IC called DC to DC. So this is the DC to DC IC, also referred to as charging IC. So the charging IC is going to regulate this voltage and is going to drop it from 5 volts to 4.2 voltage to charge the battery, right? So from the DC to DC IC, or from the charging IC, the voltage is going to go through a capacitor, a cap called a boot cap, right? Then from the boot cap, it goes to another component, an inductor called a boot coil. So from a boot coil, VPH is going to be formed. So from this coil, you form VPH, which is which is already 3.7 to 4.2 volts. You get? Now, from this voltage, it gets distributed to your entire motherboard, right? Now, again, from DC to DC IC, you have another line that is called charging outline. Okay, and this charging outline goes directly to the battery. To the battery connector, right? This is the battery connector. Battery connector. Of course, through 2 or 3 capacitors, just to filter out the voltage. So at the battery connector, the charging voltage is delivered as 4.2 volts, and this is the normal voltage for charging the battery. Now, as you can see, all these components that we have discussed in this charging system can break down, or they can fail. And failing, it means maybe that component has gone bad and it needs to be replaced, or that component needs to be jumped. Okay, for example, we talked about how you can solve this other system. So let's talk about how can you solve this system. So let's say the OVP IC is dead or is damaged. So if you realize the OVP is damaged, what you do, you come to close to the OVP. Of course, this is where you'll need the schematic diagrams, because schematics, they'll give you directions and tell you which exact component you are dealing with, right? So in case you have the OVP damaged, it means this other circuit is not going to work, right? Charging voltage will just come and enter the OVP, but it will not come out. So what do you do there? So what you do, you come to the capacitors, the input capacitors for OVP. You measure if it has 5 volt on the capacitor, the input capacitor. You measure the output capacitor for the OVP. You have 0 voltage. So input capacitor, you have 5 voltage. Output capacitor, you have 0 voltage. So it means the OVP is dead. So what you do, you take a jumper from this cap to the output cap. You get my point? So once you take this jumper, this other system is going to be restored. Same thing, different way. Now, in case you have DC to DC IC, or the charging IC damaged, or maybe say it has gone bad and it is not giving the 4.2 voltage to charge the battery. Now, note me well, in most cases, the DC to DC IC, in most cases, most of the smartphones, if this IC is bad completely, it will not generate the VPH. And once VPH is not generated, your phone is completely dead. What you have to do, you have to replace or reball this IC. The DC to DC IC, you have to replace or reball to make sure you have the VPH again. But now, in some cases, you have the VPH generated, but the charging outline is not generated. So in that case, that means your phone will not generate the 4.2 voltage to charge the battery, but it generates the VPH. So it means your phone is going to be working as normal, but it cannot charge the battery. So what you can do, the solution to this, you can either reball this IC or replace this IC. If you cannot do that, or maybe you don't have the requirements to do this, you can take a jumper. And taking a jumper, the most easiest way that you can do is to take a jumper direct from the V bus, the 5 volts, and you bring the jumper to the V bat. Okay, you take the jumper from the V bus to the V bat. Now, if you do this, it means you're feeding the battery direct from the VBus. The challenge with this is the moment you do it, the moment you do this, you connect the battery on the battery connector, the phone will start charging itself even without connecting the charger. So that's the challenge with this jumper. This jumper will work and the battery will charge perfectly well, but the problem is the phone will be on self charging. Okay, now to solve this, there is a small component that you can put in between here, a diode you can put in between here, and I will show you that in the subsequent video to make sure you don't have this voltage again coming back to the VBus. So you put this, a diode that is going to stop the voltage from rebouncing back to the VBus, and you do that, your phone is going to charge perfectly and will not be on self-charging. Okay, now let's say the DC to DC IC generate 4.2 charging outline, but after generating the charging outline, it is going to the battery connector, but maybe this line right here is broken. So what do you do about it? So what you do is trace where the blockage is. So if you trace that, then you can take a jumper from the DC to DC IC, the charging outline, the capacitor. You take a jumper. If you measure the capacitor on the charging outline and you have 4.2 voltage, but you don't have it on the battery connector, so what you do, you can take a jumper from here to VBAT test point, and once you do that, your charging is solved.